Hello. Are you getting quality problems like this on your plastic parts, where you're getting an extra thin layer of plastic around your parts? Well, this is known as a defect called flash. And in this video, we're going to discuss more about this issue, how it's caused, and how we can solve it as well. So, on the process side of things, one of the first things I would do is look at the clamping force, especially if I had flash like this, where it's what we would call split line flash. So this is the split line here. This is where the two halves of the mold separate, and the flash is occurring out through the split line. So I would look to close that mold, squeeze it a bit more tighter, clamp it over more. So setting the clamping force higher would be one of the first things I would be looking to do. Secondly, then, I need to know when the flash is occurring. So is it happening during injection phase, or is it occurring during the holding phase? Um, Now you may ask, well, how do I find what phase it's happening? Okay, let me just quickly try to draw a curve here, pressure curve. So I have my pressure axis and I'm going to put a time. No, I'm not going to put it there actually. Just going to put it down here. Pressure. So that's the pressure axis, and then I have time and injection time on the bottom axis. Now, as I increase my injection speed, my graph is going to go up like this, and the pressure is going to keep increasing. Okay, well now I just might draw that a little bit steeper like that. Okay, the pressure is going to keep increasing as I keep injecting. Now, if I keep injecting until the part is full, I'm going to get my curve going up very, very steeply up like this. The pressure is going to keep going up very high because the part is full. So what we generally want to do is, once the part is 95, 98% full, we want to come down to a lower holding pressure. Something like that. Okay, now we could say this point is, my lines are really not very straight, but okay, switch over. We're going to call that the switch over point, and we're saying it's at 95 to 98% full. 95 to 98% full. The mold is. And that's fine. So now we're switching over at that point, and we're trying to keep the pressure down. So the part is 95, 98% full. Now, usually this is done by visually looking at the part. And if you see the part with some sink marks in it, maybe a very thin wall part, you may have a short shot or small short in it, and we would call that 95, 98% full. Now, things start to get tricky when we work with multi-cavity molds, where we have many cavities into one mold, and if the mold is not completely balanced and we're not getting flow going to each and every cavity at the same time, then you can get one cavity overpacking and other cavities not being packed out. So this switch over position can get a little bit more trickier. Okay, but let's presume we're hitting our 95% full, and that's what we want. We want to check that we're 95, 98% full. We're not overpacking the part. because where we don't want to be is off up here on this side of the curve, up very high with the pressure, and then switch it over. We're overpacking the part, overpacking the mold, and the mold will want to open up, and the force inside that cavity is actually trying to push the mold open. Okay, so next I would look to lower the injection pressure. So look to lower the injection pressure. Now you can do that by if you're flashing during injection phase, which is generally the case, but not always, but generally the case, we flash during injection. Now, if I just take this another step forward and we look at the speed. So I'm going to just put down IS for injection speed up here. And I'm just going to graph that again. So we're going to start off with an initial fast injection speed. And then we're going to lower that speed right down to maybe 60-70% down. We're going to reduce it maybe 60%, so from the initial fast injection. We're going to reduce it right down, and we're going to do that before switch over. So you might say, well, okay, how much before switch over? What, that distance there, or that time? I would usually go somewhere between 2 millimeters for an electric machine, and for a hydraulic machine that's not so responsive, maybe looking at about 4 millimeters before my switchover position. Now, what's going to happen then to my pressure? Well, I'll just draw it in yellow here. What's going to happen to your pressure, this is your melt pressure, it's going to take a dive. It's going to drop off. Generally, this is what will happen when you reduce the speed. The pressure will reduce. Now, it may be a gradual reduce, or maybe a little delay in reducing that, but the pressure will generally reduce. And what I like to see, let me just go back here a bit. What I like to see is this angle here to be somewhere around 45 degrees. A nice 45-degree drop in that pressure before switchover is a nice place to be. So by profiling your injection speed, you can reduce your injection pressure. And you might say, well, that's grand if I'm flashing during the injection phase, but what about if I'm flashing during the holding phase? Well, then you need to reduce your holding pressure, the holding phase pressure. So what and I'm not sure what color I should use here. I'm just going to use a white again, but put it in a dotted line. So we look to reduce that packing holding pressure, and we could do that as so. Once we have reduced our switchover pressure, so our switchover pressure is now down here, and we can reduce it down the packing holding phase. We can reduce that pressure even down further, as opposed to when it was again, I'm going to just use a green here. If we were switching over at this peak pressure, at this high pressure, if we try to drop the pressure too much during the switchover into holding, what tends to happen is the screw will just bounce back and forward, giving us very inconsistent shot to shot weight as well as dimensions. So by lessening that drop, getting really messy here now, by lessening that drop, we can look to even reduce the switchover pressure but also reduce the holding and packing pressure. Okay, so that's some things you can do to lower the pressure, injection and holding. Next, let's have a look here. Reduce the melt temperature. Okay, we could reduce the melt temperature. We would be hoping to increase the melt viscosity. Reducing the melt temperature makes the plastic more resistant to flow. It becomes thicker as such and more difficult to flow. So the viscosity becomes higher. Viscosity is resistance to flow, essentially. So by reducing the melt temperature, we're increasing that resistance to flow and increasing the viscosity. Now, I could also look to reduce the mold temperature. Now, the mold temperature essentially is helping the plastic flow in the mold. As the temperature is higher, it allows the plastic to flow easier in the mold. So by reducing that mold temperature, there becomes more resistance to flow. The viscosity of the material increases as such. So you may get some benefit by doing that. However, you are working within limitations of the material supplier, and you may have some success with that, but not always so much. Okay, next I would look at the mold. Now, the problem is with the flash, as you can see here, the flash on the part. So we have lots of flash on the part here in this area. So what we need to do is get your plastic part, have a good look at it, know exactly where the flash is occurring, and then have a look at your mold. Preferably if the mold is on the bench and you can disassemble the mold, the cavity and core, open it up and have a good look in there at the mold and see if there's any flash or damage on the mold surface itself. On the split line, on pins, wherever that flash is, you need to have a real good look at it under good magnification and good lighting as well. Taking a picture of it, recording it, and then discussing it with the team on how to fix the problem. The core cavity may need to be welded, and so on. Now, the fit tolerance. This is the tolerance when we're using inserts in the mold and we're assembling the mold as such, the core and cavity, ejector pins, so on. So there's a fit. That's how tightly these parts fit together. That fit tolerance is very important, and that's something you may need to check as well, especially if you're getting flash down between those holes or on those pins. Okay. If you could help me out, it would be great. If you got some value and use from this video, it'd be great if you could like and subscribe to the channel. It just helps out the channel and it gets more people just like yourself that's interested in this kind of content, and they're able to find it too, and it helps them out. So if you wouldn't mind like and subscribe, and the bell icon, just it'll notify you when I upload new videos just like this. Okay, so there's 6 good steps in troubleshooting this flash issue. I hope you get some value out of that. By the way, excuse me now, turn that off. By the way, I do run courses on injection molding troubleshooting, injection molding fundamentals, and other courses on the subject of injection molding. So if you are interested in that, you can check out the links below. I also offer one-to-one coaching, so if companies or businesses are having quality issues with plastic injection molded parts in manufacturing them, they can reach out to me as well. I'd be more than happy to talk to you. I also run a product design and development company, and we offer mold making and mold molding services here in Taiwan. So my contact details are there. By all means, drop me an email, or if you prefer, my WhatsApp is there as well. Okay.